Okay, so we're all set. I hope everyone can hear me. I'll begin now. With Shane, I'm an assistant professor at McGill. I'm going to talk to you about some of the work that we've been doing in my group, which is highlighted by these famous people from London. So first off, before we get into the content of the talk, a little bit about myself and my research group. So what do we do? Well, we're the Software Rebels, and that's not just a cool acronym. It actually stands for the things that we do in the group. So the RE in Software Rebels stands for repository. So what do I mean? Well, development data is kept for archival purposes. Typically, software development produces a lot of data. So we create issue reports and we store them in tools like Bugzilla. We create store them in things like Git, and we even store code reviews in repositories like Gerrit. And typically these sit around on the shelf and you leaf through them once in a while to try and understand some context of a code change or context of a code review, that sort of thing. What we try to answer in this repository excavation direction of our work is, what if your software repositories could talk? What if they could become an active part of your software development process? So what we do, my students and I, we mine through historical development data in search of development gold. Today I'm going to talk about two studies. One is on contentious reviews. The other is on community evolution. So how does code reviewing feedback change as an organization evolves? So first, let's talk about contentious reviews. Okay. So again, we're going to go back to our gurus, the Beatles, and we're going to extract some knowledge from their quotes. So they have a famous quote where they say, when the broken-hearted people living in the world agree, there will be an answer. So what they're trying to say, obviously, is what happens when reviewers disagree. And that's the question we try to answer in this piece of work. So reviewer opinions about a patch may differ, right? So an author may upload their awesome patch to Gerrit, and a reviewer 1 may come along and say this is great, +2, and a reviewer 2 may come along and say -2. So the question that Toshki was interested in answering is, how do we proceed? How does code review proceed when we encounter patches that elicit opposite opinions? So you end up with code reviews that we call contentious. So reviews that get pluses and minuses. And I'm going to outline what the study kind of focused on. We wanted to know, how often are these contentious patches occurring? What's the trend over time? Are they becoming more prevalent, less prevalent over time? Then we performed some qualitative analyses where we tried to understand what drives contentious patches to be abandoned, and the alternative scenario, how are concerns addressed when the contentious patches eventually merged into the code base. So, okay. So in order to study this, we needed some data. So for this talk, I'm focusing on two studies where we focused on the OpenStack development process. So the question that naturally comes up is, why did we pick OpenStack? Well, in order to study these contentious patches, we need a lot of data where there are multiple reviewers commenting. And what we found is that when we looked at the code review repositories that we had open access to, so we looked at OpenStack, the Qt framework, Android, Eclipse, and LibreOffice, what we found is that the percentage of multi-reviewer patches in OpenStack was much larger than the others. And also, there's just way more patches in the OpenStack environment. So we ended up selecting OpenStack for analysis because we need those multi-reviewer patches. Okay. So the first question is, how often are contentious patches occurring? So what we did is, for each patch, so for each review, we analyzed it by grouping it into a pattern. So we started out by saying, is there a strong positive score on this review? If yes, then we check for a strong negative. If yes, then we call that pattern strong positive, strong negative, +2, -2. If no, we call it strong positive, weak negative, and we end up with four patterns of contention. Okay, and it's important to note that we handle patches with several revisions. So we only call a contentious patch contentious if it elicited opposite opinions on the same revision of a patch. So the example on the left, where we have a +2 and a -1 on revision 2, would be considered contentious, whereas the example on the right, we would not consider contentious because the opinions came on different revisions of the patch. Okay, so how often are we finding contentious? So it turns out that in the OpenStack environment, contentious reviews account for 26% of all OpenStack reviews. So what we're finding is that the vast majority of those have only weak opposition. So we have either strong positive, weak negative, or weak positive, weak negative, accounting for about 26%. And the other 2% are the extreme cases where you have a very negative person accounting for that. But overall, all four of these categories account for 26% of all the multi-reviewer stack. Okay. The next thing, how often are these patches created? And the patterns are kind of what you would expect. So when you have a strong positive and strong negative score on the same revision of a patch, you have about a 50-50 chance of getting your patch eventually integrated. When you only have weak opposition and strong support, you tend to have a better chance of getting integrated. Weak support, strong opposition, chance of being integrated, and weak is actually skewed towards acceptance, which is nice to see. So what do we take away from this? Well, first we found that contentious reviews are not rare, so it's something that organizations should be aware of and probably have some sort of policy for managing. And contention is not a showstopper. So there are cases where contention occurs, but it's not preventing patches from getting created. So the next thing we wanted to know was how does this trend look over time? So what we're showing here is measurements on a monthly basis of how many contentious reviews there are in absolute terms. It's important to note that the y-axis is on a log scale, so we're seeing almost a log linear growth in terms of the different patterns. So we see it's starting to taper off now in recent months, but yeah, there's a lot of contention and it's tending to grow over time, at least in absolute terms. When we talk about it in relative terms, we still see some growth. So over the months, we've seen more and more contention. We've kind of grouped these into two categories, one where there's weak negative, when there's weak negative and when there's strong negative, and both seem to be growing over time. How do the integration rates look over time? And what we're seeing is that they're roughly stabilized now. There were some interesting periods that I'd be interested in chatting with OpenStack developers about, if there are any in the audience. The period here where we see a noticeable jump in the integration rate of the strong positive, strong negative, and weak positive, strong negative. So even the patches that had a strong detractor have seen growth in their integration rates, which, yeah, it's hard to know exactly what's going on there, but if somebody's around who would shed some light, that would be cool. Okay, so what do we take away? Well, contentious reviews have been growing over time, and the integration rates have roughly stabilized. So let's move on to some of the qualitative analyses that we performed. So how did we do that? Well, we started out by selecting the patches that have strong positive and strong negative scores on them. So that was about 684 reviews. that have these positive and negative scores, and we picked that category because we wanted to study these really, really contentious ones, the ones that get people saying this is the best thing since sliced bread and this is the worst thing ever. And we selected using a sampling technology that's used for polling, statistical polling. We selected a sample of 362 reviews for manual analysis. And this sample is selected such that we have a 95% confidence level in the sample that we've selected with a confidence interval. So that means when I report these numbers, imagine that there's a plus or minus 5% on them, okay? So now that we have a sample, what did we do? Well, poor Toshki went through each one of these reviews and tried to identify what the function was. So in this case, maybe it was a test coverage issue. And what he would do is he would pass along his categories, and I would check them to say whether I agree with his tagging or not. So once we had a discussion and we reached a consensus for each review, what we ended up with was a categorization of all of these sampled reviews under various categories that we came up with. So things like test coverage, whether there were side effects triggered, whether there was an alternative solution, or whether the patch was actually already fixed by previous patches. And then what we did is we lifted these categories into cohesive groups. So for example, test coverage belongs to QA, side effects and alternative solutions are design issues, and already fixed maybe belongs to an unnecessary contribution category. And from those groups, we ended up lifting them to sub-hierarchies. So there are some patches for which there are internal concerns about the content of the patch. And then there's some that are external concerns that are related to things beyond the content of the patch. So what we ended up with after doing this study of the abandoned contentious reviews is this hierarchy that I'm showing you here. And I don't really have time to dig into the details of this, but the one thing that was that about 60% of the contentious patches were contentious because of external concerns. So it's rarely the actual internal content of the patch that is leading to this abandonment of contentious patches. It's things, the underlying issues already fixed by another patch, or there's some patch dependency problem, or there's branch placement issues, these sorts of things. So what do we take away? Well, concerns beyond the patch scope are more strongly linked with abandonment than concerns within the patch scope. So the next question was naturally what happens in the patches where concerns are resolved, and we applied the same technique to categorize patches. We ended up with a hierarchy like this. And what do we take away from this hierarchy? Well, about 56% of the patches are eventually merged due to issues that were indirectly addressed. So these are things where the reviewer actually was persuaded to remove their score. These were things like the release schedule being updated, so the patch eventually gets in, that sort of thing. And it's rarely, again, internal, directly addressing things. So it seems like negotiation skills to get your contentious patches merged. So again, concerns are often addressed through negotiation and scheduling issues more often than actually changing the content of the patch. So what would our gurus say about this study? Well, life is short and there's no time for fussing and fighting, right? So it seems that we do a lot more negotiation than we would think. So the second study I wanted to chat about, and I'm not sure how I'm doing for time. Am I okay for time? Okay, cool. So the second study I wanted to chat with you guys about is about community evolution. And this was work that was done primarily by a master's student of mine, Ray. So back to our gurus, they have a famous quote where they say, And in the end, the love you take is equal to the love you make. So what they're trying to say with this quote is that you get what you put into code review, right? So an example of that, if it's a patch, one reviewer might just immediately provide feedback that says it looks like code to me, +2. Whereas a more seasoned reviewer might provide some more useful feedback. Do you consider alternative designs, this sort of thing? So what we wanted to do is analyze a large corpus of reviews to see what kind of feedback is being provided by an organization and whether that changes as the organization grows, as reviewers grow, or as the workload that they're under evolves. So those three dimensions were community aging. So how does reviewing feedback evolve with respect to community aging, with respect to reviews, and with respect to reviewer workload? So first, community aging. So how do you, well, we didn't have the resources to do it manually, so we applied text mining technologies. So what we did is first we would get all the inline from the OpenStack community, which ended up with around 506,000 comments. And then we fed these inline comments to a topic analysis tool is going to try and group co-occurring cohesive topics. And with those topics, what we would do is we would check how the topic scores change as the community evolves. So we would look at how prevalent these topics are as the community ages, for example. So the particular type of topic performed is called LDA. I'm not going to go into the details, but just think of it as we fed all 506,000 of these comments into this LDA magical black box. What it spits out is the most relevant words for a topic and how prevalent that topic is. So we would get something like log, debug, warn, anywhere, bit, level, dashboard, and a 0.8. So what we did is, given those most relevant words, scan through the reviews and that score, that particular reviews, some of these most relevant words, and come up with a name. So for example, this comment that I'm showing you below is an OpenStack comment that was given a score of 9.4 out of 1. So it's very highly related to this topic, and it says how to enable trace log level in config file. Enabling the trace would enable debug also. So this seems to be related to logging. So that's where name logging for this topic. And then what we did again is we lifted these topic names into cohesive categories. So logging, release engineering, performance, we grouped them into operations, and so on and so forth. And what we ended up with is this visualization of the topics. So we used this visualization to drive our grouping that I showed you in the past. So this operations testing and that sort of thing is based on how closely clustered the different circle represents a topic, and we were able to group them into cohesiveness. So the first question is, how has community feedback changed as the open aged? And some of the things that we're noticing, things like key errors, exception handling, object names, software design related topics, they've tended to decline as the community has aged. So the community has provided less feedback with respect to these topics as the community has aged, which is a little scary at first. But there are other things that they've started to emphasize as the community has aged. So it seems issues have grown in a significant manner. Formatting issues, we've seen a growth in that as well. So as the OpenStack OpenStack community has aged, the community has focused less on patch design and more on networking and patch formatting. So what we did now, so instead of looking at the community over time, we look at reviewers over time. By reviewer expertise, by looking at the number of reviews that they've done prior to this particular review that we're measuring. So we get a kind of coarse-grained reviewer experience metric, and then we study that, how comments change with respect to that experience. And what we find is that system-oriented topics tend to increase as reviewers accrue experience. So we're finding that operations like logging and performance issues, server-related issues with respect to nodes and the open object names, function headers, and general social communication tend to increase as the community viewers accrue. Interesting one here was really this social communication, and what our hunch there is that community, so the senior members try a little bit more to reach out to junior members and encourage them to continue general social communication. Our hunch is that, yeah, there's some push from the senior members to try to be contributors. What we're also noticing is that things like formatting, they tend to decrease as reviewers accrue experience. So reviewers spend less time on low return on investment topics like formatting as they accrue experience, which is nice to see. So as OpenStack experience, they tend to comment more on system-oriented topics, and less on kind of versus spaces. Okay. So this was another way we had for quantifying reviewers' scores. We wanted to know, as you accrue more workload, so you have more reviews to work on at the same time, is there a change in your commenting practice? And what we found out kind of is that the core experience or experience score and your workload score was very, very high. So this is a 0.68 out of 1, so 70% correlation. So the insight from the score is also out. So with heavier workload, you tend to focus more on these system-oriented topics and less on the formatting thing. So similar observations for experience were reported. So what would our Beatles have to say about this? They don't always have the most insightful comments in their songs. Sometimes they're just singing about girls. So yeah. So that was a quick run through of a couple of studies that we've done recently where we mine Gerrit code reviews to try and understand reviewing processes. So just a summary of what I talked about. So code review is a source of developer resources. So we spend a lot of time on code review, and some people feel that it's not always useful. So what we did is we set out to study the code review process, and we kind of phenomena. One was contentious, just that attract both positive and negative feedback, and we had some observations there. We also studied how code reviewing feedback evolves with respect to community aging, reviewer experience, and reviewer workload. We had some observations there. So just to wrap up, my name's Shane. I'm an assistant professor at McGill University in Montreal. My contact details are there. You can follow my research group on Twitter. If you're interested, you can email me at the email there.